All right, universal gravitation. Universal gravitation is basically Newton's fourth law. We've talked about his first three already. His fourth law is known as the law of universal gravitation. And what it really shows us is the relationships between two bodies, two masses, the gravitational force between those, and how that force is affected when the masses increase or the distance between those two masses increases or decreases. Okay, so that's Newton's fourth law. So gravity is a weak force. If I am in close proximity to a calculator or my cell phone, my gravitational force is not strong enough to pull that calculator or that cell phone towards me. Or with an iron nail, basically. If I take my finger and I place it towards an iron nail, that nail is not going to move as long as my finger does not touch it. But if I take a magnet and I place the magnet near that nail will then move. So the magnetic forces are stronger forces compared to gravity. Gravity is said to be a weak force. Okay, and gravity does act over long ranges. Okay, so all the planets in our solar system are revolving around the sun. The sun's gravitational force extends millions and millions of miles throughout this universe, causing these planets to orbit around the sun. So it is definitely a long-range force. So his fourth law basically says that any two objects in the universe attract each other with a force. So any two objects that have mass will exert or attract each other with some sort of gravitational force between them. And those relationships between the mass and the force is a direct relationship. They are directly related or directly proportional to the product of their two masses. Meaning if I multiply those two masses together, that relationship will be directly related to the force. And I'll talk about that here in a second. They are also inversely related or inversely proportional to the square of the distance between them. Okay, so what this says is that as more mass is added, so as mass increases, the force between those two objects also increases. So as mass goes up or mass gets larger, the force between them also increases. So in other words, if the mass doubles, meaning it is twice as large, twice as massive, because they are directly related, then that force between those two objects also doubles. It also increases by a factor of 2. Now, if both masses increase, so if I increase one mass by 2 and another mass by 2, if I double each of them, then what I get is a force that is 4 times what it originally was. It is quadrupling, okay? Because I originally had one mass, or a mass of 1m, and I am doubling that mass. So now it's 2m. And if I take that original mass, which was 1m, and I double that as well, I get 2m. Now it's directly proportional to the product. The product means multiplication. So if I multiply these two together, I get my force of 4. So if both masses double, they both get larger in size by a factor of 2, then the force between them increases by 4 times its original amount. Now, force is inversely proportional to the square of the distance between those two objects. Okay, so the further two objects are from each other, the more distance between those two objects, the weaker the force is going to be between those two. So as distance increases, force goes down. Okay, that's that inverse relationship that we're talking about. Now, it's not as simple as saying, well, my distance goes up by 1, so my force goes down by 1. It's not that easy because it's the inverse square. Okay, because in my equation, which I'll show you on the next slide, my distance is in the denominator and it is being squared. So if the separation distance doubles, meaning the distance increases, then my force is going to get weaker. And it's going to get weaker. It's going to be a fraction. It's going to be a fourth of what it originally was. And if that distance is cut in half, meaning it gets shorter, then my force between those two objects is going to increase. Remember, we're inversely related. So as the distance decreases, my force is definitely going to increase. Now here's my equation. Here's my universal gravitation equation. And what this basically says is that force is equal to G, my gravitation constant, times the two masses that are in question, all divided by the distance squared. So this is D2. This should really be D squared. Okay, so force here is, or excuse me, F is commonly written as Fg, and it is the gravitational force. So it's the gravitational force. My m's here we're familiar with. These are my masses. So we're comparing two objects. Each object is going to have mass. Each object will experience a gravitational force between together. D is also something that we're familiar with. D is the distance between those two objects. And big G here, capital G, is referring to the gravitation constant. Gravitational constant. And that word constant means that it's going to stay the same. So this number here is going to be my value, my magnitude for big G, my gravitational constant. So what this says is that the force of gravity, or the gravitational force, is equal to my gravitational constant multiplied by my two masses. So it's the product of two masses, all divided by the distance squared. This should be a square.